In today's modern geospatial world, it is easier than ever to access petabytes and petabytes worth of satellite data within a fraction of seconds, thanks to stack specification and couple of libraries available in Python, which makes our life very easy. And in this video, we are going to explore them with a real life use case. We will access Sentinel-2 data for our own area of interest. Let's say we are going to go ahead with a farm boundary, and then we will access various vegetation indices like NDVI, EVI, etc. and see how we can procure the data, analyze the data and export the data for our own farm without ever having to download the entire satellite data in one go. This is going to be an amazing video, so make sure to watch it till the end. If you are new to this channel, please make sure to subscribe and hit the bell icon so that you will get notification whenever I drop new geospatial video. Without any further delay, let's get started. If you're interested into reading about how we are going to do this, you can always go to this link which you will find in the description and read the blog. In this particular blog, you will see all the code snippets as well that we are going to use throughout this video. You can see how we can use Python to download the Sentinel data within couple of seconds. Now, if you are not familiarized with Python, you can just simply go to the courses and grab the Ultimate GeoPython course as well. At the moment, this is at a discounted price of 1699 rupees, that's roughly $20. So you can just go to this video and have a look at all the videos that we are going to cover in this courses. There are more than 97 chapters, this means videos available, which takes care of everything from introduction to Python all the way up to creating the web application as well as managing the big data workflows, etc. Now coming back to the blog, we are going to go ahead with PyStack client and ODC stack as two of the main libraries. So first thing first is I will open my terminal. And now I am going to create a new folder on my desktop. So I will just simply go to desktop and create mkdir pystack, cd pystack, and now I am going to create my virtual environment. It is absolutely important that whenever you are working with Python, you have to create a virtual environment for your own use case so that these different libraries of different projects that you are working will not get mixed up. Now there are various ways how you can create virtual environment. I use VENV, someone might use Anaconda or Miniconda, or someone might use Poetry. That's totally up to you. For now we will stick with virtual environment. So I will simply create this virtual environment and I will activate this. Alright, now there are few things that I need to install. So the first thing I will install is Notebook, because we are going to create a notebook which you can also access after this video, where all the code blocks will be available. But when you will be creating a production ready application, you don't need to install Notebook, and that's why you will not see Notebook written over here. Okay, but the other two libraries that we need to install are PyStack client and ODC stack. Now if you are going to deal with Planetary Computer for your stack specified satellite data, you might also need to install Planetary Computer Python package. But in this video we are going to use Element 84, so I will not be doing that. Alright, let us check our terminal, and it looks like all the installations are done. Now generally I never do pip install something. I always create a requirement.txt file first and then I write everything in it. Why? Because I cannot tell you how many hours I have wasted by simply ignoring this step and doing the pip install and figuring out or thinking that I will do it later, just to realize that I never did it. So it's always a good practice that you do this requirement.txt and you write everything in it. So I need Notebook, then PyStack client and ODC stack. We also need RioX array, so let us write that over here. So RioX array. Okay, now that's all, and then I will again do pip install -r requirement.txt. So this will make sure that all the packages that I need are available over here, and if I need to install any more packages in the future, I will just update this requirement.txt file. Alright, so far so good. Now I will open this folder in my code editor. I am going to use VS Code. Feel free to use anything else that you are comfortable with. And the first thing I will do is I will create a notebook. So I will say imagery.ipynb. okay, and this is our notebook. Now I will select my kernel, which will be the env that we just created, and I will start by first of all importing the client. So to test that out, we have 3 imports that we need to do. So from PyStack client import client, from ODC stack import load, and also import ODC geo. We are not importing RioX array at the moment, but we will have a look at it later. Okay, it is taking some time, but it is actually doing that import. Okay, so it gives me the surety that all the packages that I need are available over here. Now the first thing that we need to do is start setting up the variables. So there are few things that we will need whenever we are creating a PyStack based Python application to fetch the satellite data. First thing we need is the stack catalog. So where are you going to fetch this data from? There are various stack catalogs available. So if you are interested into understanding, you can just simply search for stack browser, and you can go to this first link where you will see that you can either put the stack API or stack catalog link if you know, or you can have a look at all the available stack catalog indices as well. So for example, I can see that there is a Copernicus data ecosystem. So if you are using Copernicus, you can have a look at the Copernicus stack catalog, and you will also see Sentinel-1, Sentinel-3, Sentinel-5 and many more of such available catalogs. We are going to use element 84, so I will just simply search for element 84, or let's say I will just simply do 84 as a search. Probably I will need to install, or I can search for earth search, and there you go. So this is the catalog that is been maintained by element 84, as you can see over here, and this consists of Copernicus DEM, GLO30, Landsat, Sentinel-1, Sentinel-2, NAIP, DEM, etc. So all of this data is available to us, and in this particular video we are interested into Sentinel-2 collection 1 L2A, right? If you want to know more about the stack specification, make sure to write that in the comment, and I will make another video just explaining what is stack specification and why you should care about it. Alright, but for the moment we have set our eyes on using earth search element 84 as our stack provider, right? Once that is done, then we need to actually mention that. So how do we do that? We will just simply create a client. So I will copy this link and I will explain you. So we are creating a client by mentioning this PyStack client, and we are saying that open this particular link. Now if you open this link on your browser, you will also see the data, which consists of couple of links, and this is the format that is set by the stack specification. So any stack specification link that you pick up, it has to have all of these various links, and one of the most important link is the collections, because when you will go to these collections, this is where you will see all the available products. So when I go to collections, you can see that there are various products available, but obviously this is a JSON data and it is little bit tough to read, and that's exactly why this PyStack client is helpful to us. Now once the client is defined, we need to now define the product. So load the stack collection. So which collection are we interested in? If you have paid attention over here, we are interested into Sentinel-2 collection 1 L2A, which is the name that is also written over here. So I will simply capture this name and I will paste it over here. So this is the collection that I am interested in, and if I want to check whether this collection exists or not, I can simply copy this, go to this element 84 collection link and just paste it over here. If it gives me the result, this means that it is correct. If I, let's say, mess this up and if I write Sentinel-2 C2 L2A, you will see that I will get the error saying that not found, which means that the name of this collection or the name of this catalog is not correct. Okay, now that we have defined this, the next thing that we need to define is the date, or let's say all the filtering parameters that we are interested in. So if I go back to the block, you can see that the first filtering parameter that we want is the geometry. Obviously, because we need to fetch the Sentinel data for some geometry. So we need to give that geometry. Now if you are interested into drawing the geometry, you can just simply go to geojson.io, or if you have your own geometry, that is fine as well. We will need feature in a GeoJSON format. Alright, now let's go to Nasik and let's try to do standard satellite so that we can see some farms, and there we go. So let's try to capture this one big area. Okay, so I can either draw it as a complete geometry, or I can just simply bring the rectangle, totally up to us. In this case, let me bring just this rectangle. Okay, now I will copy this geometry and I will paste it over here. So geometry for the area of interest, and my geometry is this. Okay, make sure that you are copying the geometry correctly and you are not copying the entire GeoJSON, but you are only copying the geometry of that particular feature. Okay. Now the next thing we need to do is specify the dates, because as Sentinel-2 data gets repeated every 5 days, if you just pass geometry, it will not suffice. You will also need to pass the date. Now there are various ways how you can pass the date parameter. If you know the correct date on which you are interested into seeing the result, you can just specify that date. But if you are not sure about that, you can also specify the complete month or a complete year. Or if you know that you are interested into a particular date range, you can also pass that date range. So let's have a look at all of these three. Okay, so the first we will try to do is a specific date. So now let me open a code block. So load stack catalog for a particular date. Okay, so let's say we will do date is this 21st of January 2024. Alright, now it's the important thing, which is running the PyStack client to find out the available items within your date and within your geometry. Alright, so how do we do that? Let me copy this and then I will explain it to you. So what we are doing is we are using this client that we declared earlier, and then we are passing couple of parameters. So the first one is a collection, which is going to be this collection, and notice that if you want to pass multiple collections, so if you are interested into Sentinel-2, Landsat, NAIP, this DEM data, everything in one go, you can also pass that. You can also provide multiple collections. Then the next thing is the geometry, like finding out all the tiles which are actually intersecting with this geometry, and then the date time, which is where we are mentioning this one particular date, right? Once that is done, we can just print all the results available in a dictionary format. Alright, now if I run this, you will see that first we are getting client is not defined. We need to run this particular cell, and it's done, and now it's time for us to run this cell. So as you can see, we are getting no results available. This is because for this particular geometry, there is no data available on this particular date. Maybe if we try to change the date, we might see some results. But as you can see, we will have to keep playing with it in order to see the results, and probably that's not the very easier way to do it. Second is that we can just provide the complete month. So instead of providing it as 26th of January, 25th of January, I will just say that okay, find out everything within the January of 2024, and immediately you will start seeing the results. So as you can see, we are getting couple of results. So we are getting result on 29th of January, then we are getting the result on maybe some other date. If you want to print out the items, you can also do something like for item in item collections. We can for the moment just print out the item. So we will say print item.id. Okay, and now if we run this, you will see that we have 1, 2, 3, 4, 5 items available during the January of 2024. As you can see, the dates are also kind of visible. So 29th, then 19th, then 14th, then 09 and 4. So you can see that almost every 5 days we have data available. But between 19 and 29 there is no data available. So it took like 10 days of gap. But if you see like 19 to 14th, then 14 to 9th, and then 9 to 4th. So almost every 5 days the data is available. Alright, this is about getting the dates for the entire month. But what if we have the date range? Let's say I am interested into getting only the data between 1st of January till the 15th of January. I can also do that. And this will now only spit out the dates between 1st and 15th. So you can see there are three ways how you can pass the date. You can directly pass the date, you can pass the entire month or even a year, or you can pass the date range. Now depending upon your use case, you can decide what you want to do with it. Okay. Now what about other filters? So far we have added only the collection as one of the filters, the geometry as one of the filters, and date time as one of the filters. But if you pay close attention to this, you will see that there are various properties available. So you can see that now, as you can see, there are also various other properties available. So if you see properties over here, you will see something like created at, platform, constellation, instrument, EO cloud cover, EPSG, Centroid, etc., etc. All of these properties can also be utilized whenever we want to do a query. So a very simple thing that we want to do is probably spit out the cloud cover and then check the cloud cover, and let's say we want to omit everything that has cloud cover less than 50% or something like that. So how do we do that? We can define a filtering object. So a filter object saying that okay, do cloud cover where it is less than 0.2, meaning like find out only the items where cloud cover is less than 20%, right? So 0.2 is because the cloud cover is always going to be between 0 to 1. So I can say that give me everything where the cloud cover is less than 0.2. So you will get almost clear images, right? And then you can also do vegetation percent where it is greater than 25. So vegetation percentage is going to be between 0 to 100. Now this is also something that you can give, but if you are going to deal with, let's say, urban data or something like that, probably this will not make any sense. But for just the sake of testing, I will keep both of these. Once that is added, then you can just pass all of this as a query parameter. Now to define the filtering, we can just simply create a new object. Let's first give the comment. So add more filtering parameters. So filtering parameters, and we can do something like filtering params, and then here we can define the filtering param. So if you want to understand what will be the name of your parameter, you can just simply refer to these properties and you can pick up the same thing that is available over here. For example, I want to get all the values where the cloud cover is, let's say, less than 20%, right? So I can just define EO cloud cover and then I can do LT:20, meaning less than 20. Similar to that, if I want to define something else, maybe let's say the product type, which was also available over here, like a platform. So I can say that okay, I don't want Sentinel-2A, I want Sentinel-2B or Sentinel-2C. I can also define that. But for now, let us only stick with this cloud cover. Okay, so I will close this filter parameter and now I will copy everything that we had earlier. Alright, and now we will add this filter in our search operation. So to do that, we will do query is equal to filtering params. That's all. And now when I will run this, you will see that we are getting the results and gladly all three are passing this. So let us try to reduce this to something like 5. And now you see we are only getting 2 results, meaning that there is one particular item which has cloud cover greater than 5. So if I try to do something, let's say like 10, you will see that we still have only these 2 items where the cloud cover is less than 10. So as you can see, we can use this extra filtering parameters to define various queries like cloud cover, and it doesn't always have to be only numeric. You can also give things like, finding out only the information where the platform is Sentinel-2B or Sentinel-2C or something like that. You can use various of these parameters. So as you can see, there is also something known as vegetation index or sun elevation or azimuth. All of these things can also be used in a parameters for the filtering. Alright. Now that the filtering is defined, it's time for us to actually start getting the data. Now this is where the ODC stack comes into the picture. ODC stands for Open Data Cube, which is again an amazing thing which allows us to access multi-dimensional data at an ease. Okay. So how do we do that? So the first thing that we do is we load all of these items into the ODC framework. So how do we do that? We simply use this ODC load function. So as you can see, we imported odc.stack import load, and this load function will take all of these search items because all the items that we found are available over here, and then we will define the geometry is going to be this geometry which we defined earlier, and we want to group by a solar day. There are various ways how you can group by, and also you can pass various other parameters. If I open these loads, you can see that we can pass group by, where you can pass the time. So once you go into the load, you can see various params that you can pass. You can also pass the chunks, which means that how much pixels we want to load in X and Y. For now, let's keep it as empty. And when we will do this, it will actually load the data into our ODC data cube. Now when I load this, you can see that we are getting an X array data set which is of total size 178 KB. So it is not downloading the data. So imagine that we are doing all of these things, but still the data is within the source, which means this element 84, right? We have not downloaded this data at the moment. We are only referring to the data. Let me change the representation to text HTML so that I can show you better. And now you can see that I'm not sure if you can read it. Let me try to change the theme. So we have to go to code, settings, theme, color theme, and let me try to make it light. Yeah, and now it's pretty much readable. Now in this data, there are a couple of things that are available. First is a dimension. So dimension tells us that the data that is available, because if you remember, the sentinel will be a big tile, but we are clipping it to only fit our geometry. So in our geometry, there are 55 pixel in Y dimension, there are 46 pixel in X dimension, and then there are 2 timestamps available. As you can see over here, we have 2 timestamps available, right? Then there are coordinates. So as I said, like X, Y, then the time and a spatial reference system, which is 32643 because this data is in India, right? And if you open any one of this, you will see that the time is showing you 2 values. First is the 4th of January and second is 14th of January. Then you have multiple data variables. So you have red, green, blue, NIR, SWIR, etc., etc. So all the bands that are available in Sentinel-2. Then you have indices, which is Y, X and time, which is what we had a look at over here. But this gives you an idea that you are looking at a data cube which is of a multiple time as well as multiple data variable. So which means that now it is ready for you to do any kind of analysis that you want to do on it. If you want to know more about X arrays, make sure to write that in a comment saying that make a video on X array, and I will make another video explaining X array, because believe me, this is very important. This is very important concept to understand if you are going to work with a multi-dimensional array. So if you are working in climate or weather or anything like that, you are going to deal with multi-dimensional data sets every now and then, and it is very important to understand these multi-dimensional things so that you can access the data and only call the data that you are interested in. By the way, this is something that is also being covered into our GeoPython course. So yeah, if you are interested, you can just buy the course directly from over there. Alright, coming back to our problem statement. So now we have identified that okay, there are 2 timestamps, there are various variables, and the first thing that we need to do is we need to create an NDVI. So if you know the formula of NDVI, that's fine, but if you don't know, the formula is red minus NIR upon red plus NIR. So now that the reference to the data is created, it is time for us to do some analysis. Now that the data reference is created, it is time for us to actually create the NDVI vegetation indices. So let's see how do we do that. So if you don't know NDVI, you can simply go to the blog and refer to this link which talks about NDVI and what exactly is this. Alright. So the formula for NDVI is data.nir minus data.red, meaning that NIR minus red upon NIR plus red. Okay. So I will simply copy this and paste it over here. So create NDVI, and notice that we are not downloading any data or something like that. We are simply referring to these particular these particular references that we have created based on the stack specification, right. So as you can see that we are at a stage where we are creating NDVI and still we have not downloaded any kind of data, and this is the power that stack specifications and this Python brings to the table. Alright, now if I run this and if I print this, you will see that now we have the NDVI which finally became only 39 KB with a chunk of like 19.77 KB each, meaning for each timestamp you have 19.77 KB worth of data. So imagine from couple of hundreds of MBs worth of the entire Sentinel tile, we have reduced it to the chunk of only 19 KB, right. That means we don't have to download anything, all the data is available to us. And now if I am interested into exporting this, I can just simply export this NDVI into a TIFF. But remember that TIFF cannot be of a 2 timestamp. So TIFF only has to be of a single timestamp. So what I can do is I can just refer to a single TIFF. So let's say I will do NDVI 0 is equal to NDVI dot ICEL where timestamp is 0, meaning that the 0th index. So 0th index will obviously give us the data for the 4th of January, right. So I will do NDVI 0 and then I will use odc.geo.xr.writeCog, which means writing the cloud optimized GeoTIFF, and I will refer to it as NDVI 0. I will open QGIS meanwhile so that I can show you this data. Now when I will try to expose this, this will create the TIFF file for me and the TIFF file is generated over here, okay. And this TIFF file is now of a single band which consists of the NDVI data, and just like that if I want to expose the first timestamp, I will also do that. So let me replace all of these zeros with 1. Okay, let me first run this and then run this. Alright, now that my QGIS is open, let's try to bring this data. So I will just simply do reveal in Finder, and let me try to open it in QGIS. So as you see, I have NDVI 0 as well as NDVI 1, and you can see that the value is different, which actually gives us the confirmation that these are two different files. Now if you remember, we created this GeoJSON, right. Let's try to also download that and open it in QGIS. And now you can see that our geometry is matching with the data that we have downloaded. You might ask that why there are more of these pixels, and this is because our polygon is actually intersecting with these pixels. And remember that this entire pixel represent a single value, that's why we cannot clip that pixel particularly. And that's exactly how we can get the NDVI for our particular data. And just like that, if you are interested into getting any other indices, you can also just create that formula over here and run that formula. Now there are several things that we need to take care. Let's say that in our case we are not able to get the data with the exact geometry. Let's say if we are getting more data, then in that case we can actually use this Rio X array to clip the geometry with the data that is available, and then use that clipped data to calculate the NDVI and everything like that. And last but not least is understanding the scale and offset. Now that we know that there are various providers for the Sentinel data, each one of these providers have their own way of procuring data. So for example, if you are using Planetary, you might see that when you go to Sentinel-2, instead of having the band names as NIR or red, you have to define it as a B0, B05, B06, B07, etc. So depending upon which particular stack provider you are using, you will have to follow their own rules, but the general way of working would be same. Now there are few things that we will need to take care whenever we will select our stack imagery provider, and that is scale and offset. So for example, if I open this particular Sentinel imagery over here, so I will just simply go to items and I will give my item ID. So I can just get the item ID from the notebook. So for example, as you can see, the item ID is available over here. And now we will get all the information about a particular item ID. So if you search for something like scale, you will see that it is giving us that the red band particularly has a scale of 0.001 and an offset of -0.1, which means that we need to apply both of these parameters for us to get the actual correct data. So even though we were able to generate NDVI, in order for us to get the accurate value, we need to implement this scale and offset into the picture. So for each particular band, you will see that it has its own scale and offset value. Now generally with element 84 for Sentinel-2, the scale value is 0.0001 and the offset is -0.1. So we need to apply this scaling and offset in order to get the correct result. So how do we do that? So we can actually just write a function known as getStuff. So let me put that function over here. So let me write a comment saying that applying scale and offset. So what we are doing is that we are looking at the band and that particular property. So of course we are interested into getting this scale and offset, right? So now what we want to do is we want to replace this data.red. So if you remember, data.red is something that we have over here. So here we go. So you have all of these values of data.red, and let's say that you are interested into applying a scale to it. So what you will do, you will say that okay, take the data.red as it is, multiply it by the scale and then add offset to it. And similarly we will do for NIR as well. Okay. And now if we execute this, we can now use these values to calculate the NDVI again. So how do we do that? We will just simply do NDVI with this. And now let's try to export this data. To export this data, we will again do the same thing. So we will do ODC GeoXR and we will mention NDVI1 as the NDVI.iCell time is equal to 1. So let me give it a name as scaled. Okay, and if I bring this value into my QGIS, you will see that now the value is different. So you see 0.82, whereas the earlier it was 0.54, and that's why it is absolutely important that whenever you are dealing with stack specification, you read the documentation and understand whether the scaling and offsets are being applied or not, because otherwise you will be getting the values but those values will not be correct. So this is why it is also important for us to understand this scaling mechanism and apply this scaling mechanism. So that's all in this video that we wanted to cover. I hope you found this video useful. If yes, make sure to check out the blog and make sure to subscribe to our newsletter so that you can get updates whenever we launch a new blog or whenever a new video is coming up. Now before I end this video, again I would like to give shout out to our Ultimate GeoPython course, where you can learn everything about GeoPython from data to dynamic maps completely within a single course of 50 hours. Thanks a lot. I'll see you in the next one.